In this tutorial, we're going to take a look at a comparison of the three most common discrete probability distributions: uniform, binomial, and hypergeometric. And we're going to take a look at all the different parameters and meanings, the definition, the range of values, etc., expected value for each of them. So let's start with uniform. The parameter and their meanings. Well, there's only one parameter for uniform, and that's the number of items. So n represents the number of items. So for example, if it's a 6-sided die, then n is 6. If it was a 10-sided die, then n would be 10. The definition of random variable, its value is just the value of each of the outcomes. And the range of x can vary. It depends on how you define your experiment. In the uniform lesson, if you watched that tutorial, one of the examples was you had a 6-sided die, and in this game, if you roll an even number, you lose twice as much as you roll. So for example, if you rolled a 6, you lose $12. If you rolled an odd, then you won $1 more than your roll. So if you rolled a 5, then you won $6. So that's why the word vary is here. It just depends on how you define your particular random variable. The probability formula, the probability x equals to each of the outcomes, is 1 over n. So for example, 6-sided die, then each outcome has a chance of 1 over 6 in happening. If it was a 10-sided die, then it would be 1 chance in 10. The expected value formula is just 1 over n times the sum of all the outcomes. Or you can go 1 over n times each outcome individually, plus 1 over n times the next one, plus 1 over n times the next one, and that's how you can calculate the expected value. One of the identifying characteristics of the uniform is that all items are equally likely, and there's one single trial. Unlike the binomial, n is the number of trials, the number of times you're going to perform this experiment. The probability of success in each trial is p, the probability of failure is q. P plus q is 1, because there's only two possibilities, success and failure. So, and the way we normally calculate q is you're normally given p, or you calculate p, and then 1 minus p would give you q. The number of successful outcomes is the definition of random variable. So for example, if you're throwing 3 coins and you want to define it to be success is getting a tail in the coin, then the number of tails could be 0 tails, 1, 2, or 3. So the number of successful outcomes is the definition of the random variable. And the range of values is x would be anything from 0 up to n, 0 up to the number of trials. The probability formula looks like this. The probability, the random variable x equals any particular outcome, is n choose x times p to the x, p being the probability of success, times q to the n minus x. Expected value formula is just n, the number of trials, times your probability of success. And the trials are independent as the number of successes are counted. The trials are independent because this is sampling with replacement. If you were like drawing something out of a hat, so that the probability of success stays constant from trial to trial. That's one of the defining characteristics of a binomial. In a hypergeometric, n is the size of the population. There are r trials, and a is the number of successful items available. So for example, if you have a container that has, let's say, red, brown, and green balls, you define getting a red ball to be a success. Well, a is the number of red ones in there. The definition is just, again, the number of successful outcomes. The values for x can be 0 up to r. Since there are r trials, r is the largest value that x could be. The probability formula is the combination a choose x. Again, a here is the number of successful items available, times the combination n minus a choose r minus x over n choose r. Again, n is the size of the population, r is the number of trials you're performing. So that's why the sample size is actually n choose r. The expected value formula is r times a over n, and the number of trials are dependent because this is sampling without replacement. If you don't put that ball back in the container each time, then the probability of getting one the next time changes a little bit because there's one less in there. So that's why the trials are dependent, but again, successes are counted. So that's the main difference between the binomial and hypergeometric. Trials are independent. P stays constant from trial to trial. Here the trials are dependent because you're sampling without replacement, so your probability of success changes from trial to trial. And that's the end of the video.